Uh-oh, my little symbol's gone to say that it's recording. So hopefully it's working now. Awesome. If it's November 23rd and you are watching this video, I don't know if you're going to be able to finish the class in time. So hopefully it's not November 23rd. Alright? We are going to do Unit 5 Notes 2 Graph and Quadratic. So what we learned yesterday was a bunch of fun stuff. And now we're going to graph it. This is kind of cool. This little water fountain makes a parabola. Sweet. Awesome. Now we're going to graph them. Here's what we did yesterday. We identified the parts. We have negative x. We have 6. Negative x. What am I talking about? Alright, we have negative 1, 6, and 4. Opens up, opens down. I know that that opens down because it's negative. That also means my vertex is a maximum. Alright, now the fun stuff. So I have negative 6. Remember, this is negative b over 2a is equal to my x. So I have x equals negative 6 over negative 1 times 2. So x equals negative 6 over negative 2, which equals 3. So my... can't write, apparently. So my axis of symmetry is x equals 3. My vertex, then, is 3, comma... well, let's figure it out. We have y equals 3 squared negative plus 6 times 3 plus 4. Negative 9 plus 18 plus 4. 9 plus 4 is 13. So 13. Y-intercept. I know that x equals 0 when the y-intercept happens. So if I plug a 0 in, think about it. Negative 0 squared plus 6 times 0 plus 4. This is just going to be 0 plus 0 plus 4. So y equals 4 there. So my y-intercept is 0, 4. Hey, perfect. Let's keep moving on. Steps for graphing quadratics. Number 1, find the vertex. A, find the x-coordinate. Right? Obviously, we have this big fancy equation. If we didn't need it, we won't give it to you. Right? It's the first thing you got to do every time. Plug into the original function and solve the 5 y-coordinate. That's how we got 13 last time. And write as a ordered pair. Okay? All that's saying is to do this. We have 3, we have 13. Write as an ordered pair. Okay, so that's number 1. Number 2, we make a table. Alright, we got tables given to us. And we start with the vertex. Alright, now it says here, find other values. 2 values to the left and 2 values to the right. Alright, so if I start at 0, 2 values to the left would be negative 1 and negative 2, and 2 values to the right would be 1 and 2. Alright, so you could think of it as doing 2 values to the left, 2 values to the right. That would be a number line, if you're thinking about a number line. I used to always say just go over 1, up 1, whatever. Alright, you got to figure it out. Graph the function. Graph values from x and y chart, draw axis of symmetry, mirror the points on the other side of the parabola. This is a big one. Alright? This idea of mirroring. Alright? The axis of symmetry is awesome because it helps us out. But we're mirroring. Don't forget, the graph will open up when a is greater than 0 or positive. A is less than 0, negative. I don't remember. That's a V. That's my cursive. Awesome. We're on the second page. We only got 3 to go. Hey, this isn't that hard. It's just spaced out so we get nice work. So, here's what we got. We got y equals negative 3x squared plus 6x plus 4. If you don't know what to do, don't panic. Step 1 on the front says, find the vertex. Alright, so I got my vertex here. I'm going to do a fancy color we've never seen before. Negative b over 2a. So, a, b, c. That's going to be negative 6 over 2 times negative 3. Oh yeah, negative 6 over negative 6. X equals 1. Okay? If x is equal to 1, I have negative 3 times 1 squared plus 6 times 1 plus 4. That's negative 3 plus 6 plus 4. That's going to be 7. Right? So then my vertex is 1, comma 7. Alright, I'm going to get rid of this right here. Pause it real quick. I'm getting rid of this. Boom. So here's my work. Vertex 1, 7. So, here's what I do. I go to my table, and in the middle, I'm going to put 1 and 7. Okay? Now, I told you to go left 2, so if I'm thinking of a number line, I would think of 0 and negative 1, and right 2 would be 2 and 3. So every time you do this, you're just going to fill out a number line. Ooh, my number line's right here if you didn't see it. Number line. If you don't know it, figure it out. There's a number line. Alright, so here's what we do. We substitute a bunch of values. Can I extend the page? I don't want to do that, and then you guys can't see. Huh. Uh-oh. Got it all messed up. Uh-oh. So we'll just scroll up like that. Look at that, it didn't even write my 3 yet. Okay, so now, negative 3 times 0 plus 6 times 0 plus 4. 0 squared is 0. You're just going to have 0 and 4. Let's do 2 once. Okay, I'm going to have negative 3 times 2 squared plus 6 times 2 plus 4. 2 squared is 4 times negative 3 is negative 12 plus 12. So that goes to 0 plus another 4. 4. Alright, negative 1. Negative 3 times negative 1 squared plus 6 times negative 1 plus 4. So this is going to be negative 1 squared is 1. So it's going to be negative 1 times negative 3 minus 6 plus 4. Negative 3 minus 6 is negative 9 plus 4, which is negative 5. This is good practice for you. Alright? If you're not able to pay attention because I'm going through fast, make sure you get the same values when you plug them in. Negative 3. So 3 squared is 9. 9 times negative 3 is negative 27. Plus 18 plus 4. Well, 18 plus 4 is 22. So negative 27 plus 22 is equal to negative 5. Okay. Now let's clear my graph out. So a lot of the work here is going to be plugging things in, which we did substitution. You should, every time you see an X, we had to practice plugging in 1 over here. Alright, and then we had to work just substituting all those values in. But that's fine, that worked out. So now I just have my values. So I'm going to go on the graph. I have 0, comma 4. Let's do it in blue. 0, 1, 2, 3, 4. Alright, I have negative 1, negative 5. That's down here. I have 1, 7. I have 2, 4. And I have 3, negative 5. Now, one thing to note, these are not straight lines, they are curved. The other thing to note is if I ask you, you should be able to identify my line of symmetry here. Alright? That line of symmetry is going to be your vertex. We talked about this already. Now, the line of symmetry is important because if you go back to the front page and look at 3, graph the function. I can do it on here, can't I? Right here. Draw axis of symmetry. So I did that in purple right now. And then mirror the points on the other side of the parabola. Okay, so we are graphing the function finally. Here's my points. Here's how they're mirrored. If I look at this one, this is 2 away, not x. This is 2 away from the axis of symmetry. This one's 2 as well. If I go up here, this is 1 away. This is 1 away. So as long as they're equal distance, we know we did it right because that means we have a true axis of symmetry. Okay, and our axis symmetry is always just x equals 1 here in this case because that's a vertex point. So you got to know how to graph x equals 1. You also got to know that it's equal distance every time. So I showed you how to look at that. That's 2 away. This is 1 away. That's important. Some people will just put the left side on and then just count over. However you want to graph that, that's fine. The vertex here is a maximum. Alright, you can see this is the highest point in the graph right here. That's the maximum value. Awesome. I can't see anything I missed. Your vertex is right here. I put it in the middle of my chart, and then I went 2 to the left, 2 to the right. I'm able to graph it. Remember I said those are curved lines. They're not straight lined. If they were straight lines, they'd be linear equations that intersect. This is just a parabola, like a water fountain. This one's pretty steep. We would say it's steep. It's pretty straight up and straight down. Other than that, you got to be comfortable subbing in all these values. So let's try 3. Okay, 3 I'm going to start. Negative b over 2a is my vertex, or is my x value. Here, negative b is negative 2. And then it's 2a, and a is 1, so I have negative 1. Now, then I'd sub it in. So I'd have, over on the side, negative 1 squared plus 2 times 1 plus 1. Remember, this is just your equation, so that's going to equal y. I have 1. This is a negative 1. So 1 minus 2 plus 1. Negative 1 plus 1, 0 equals y. So my vertex point is now negative 1 comma 0. Negative 1 comma 0. This is my vertex. So if I'm at negative 1 here, I went 2 to the left, I'd have negative 2 and negative 3. If I went 2 to the right, I'd have 0 and 1. Now the fun begins. I wish I had more room to do these. Alright, if I plug 1 in, I'd have 1 squared plus 2 times 1 plus 1. That's going to be 1 plus 2 plus 1. So that's going to be 4. Okay. 0. 0 is easy. If I have 0 squared plus 2 times 0, all those are 0 plus 0. They don't matter anymore. So I just am going to have 1. Now you could actually, I'll do it anyways. Negative 2. I need to square that. Plus 2 times negative 2 plus 1. So that's going to be negative 2 squared. Make sure you put that in your calculator with parentheses. If you put negative 2 squared in your calculator, it does 2 squared and it tells you negative 4. Alright? If you put negative 2 parentheses squared, that's negative 2 times 2, it gives you a positive 4. Make sure you know the difference between that. That's about 35% of your guys' mistakes. Then it'd be minus 4 plus 1. This goes to 0. So this is 1. If I'm a betting guy, I know this is 4. And by betting, I mean I know it's absolutely 100% 4. Alright, one thing you guys can catch on to is this one and this one are going to be equal, and these two outside ones are going to be equal. They mirror each other. Right? If I go up here, I can go to negative 1 for my x. My y value is 0. Did I do this right? If I go to 0, it's up to 1. Negative 2, 1. 1, 4. Negative 3, 4. Can go up here. My vertex value is x equals 1 over here. So that's now my line of symmetry. That's how I get that. Okay. Then lastly but not least, you can count. I want you to see this. Alright? This is 2 away here. So what I do here, this is 2 away. The reason it's 2 away all the time, or 1 away is because we're just picking 1 away here or 2 away here. Okay? All that means is we just got some awesome points to graph. Alright, so this is -1, -2. If you can do that, you're going to be awesome at this. What is the vertex here? The vertex is a minimum. We worked yesterday doing that. You guys should be comfortable there. So now you can flip the page, and we just got to graph 3 more of them, and we're done. Alright, I'm going to go a little bit faster through these. So make sure either you can pause the video, try them yourself, and then see if I do it the same way, or your other task would maybe be to follow along on this one, and then try to pause the video on the next one. So I have -2 for a b value, so I'm going to have x equals +2. 2a is 2 times 1, so this one's 1 equals x. So I'm going to put 1 here. I'm going to put 0 here. I'm going to put -1 here. I'm going to put 2, 3. Now, I got to substitute those in. So for 1, it'd be 1 squared minus 2 times 1 minus 8. It'd be 1 minus 2 minus 8. That's going to be a -9. I'm really good at the 0 ones because it's 0 minus 2 times 0, which is 0, minus 8. Alright, -1 squared is 1. So -1 squared, that'd be 1 plus 2. Alright, so that'd be 3 minus 8. 3 minus 8 is -5. So -9, -8, -5. Let's make sure. One thing to do is you can check and make sure you did them right. So I get 2 squared minus 2 times 2. So that's 4 minus 4. So that's going to go to 0. This is definitely -8. Right? -8, -8. This goes to 0, -8. And then 3 squared minus 6 minus 8. 9 minus 6 is 3 minus 8 is -5. Okay, I need my graph, so I'm going to erase some of my work. Blah, 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 blah. I'm going to go 1, -9. So that's -7, -8, -9. I'm sorry it's off your graph. We didn't put very good numbers there. Now, let's look at this. 2, -8 is right here. 3, -5 is right here. Okay, 0, -8. -1, -5. Hey, I'm going to do something fun. Ooh, that does not look right. I had this point wrong. 0, 8 is right here. This one is right here. Now, let's do this anyways. -2. -2 squared is 4, plus 4 is 0. -2 squared is 4 plus 4 minus 8. 8 minus 8 is 0. So where do you think 4 is going to be? If you answered 0, you are correct. So I can do some more points here. -2 is 0, and 4 is 0. I'm going to have some fun. -3 squared. -3 squared is 9 plus 6 minus 8. That's 15 minus 8 is 7. So I'm going to know it's up here. Well, then if -3 is 7, 5 has to be 7. So I'm going to go 5 up to 7. Okay, so did I have to graph all those points? No. Okay, you can see, you should be able to see it starts here. It's got this nice little curvature to it. Your graphs are going to be very accurate the more points you plot. I just wanted to have some fun, so I did some more. Maybe that's why I'm a nerd or a geek. I like math. This is a minimum. It's the bottom of the hill, or the parabola. Alright, that's how you do that. Those are all the points you could have tried. I went 4 to the left and 4 to the right, or down 4, up 4, whatever you're thinking of. And your parabola looks awesome. You guys are able to get this. Now, I didn't draw my axis of symmetry. I knew it was x equals 1 because it's right here, and I'm underlining it in green right now. Okay? Then you should be able to see these are 2, these are 2. This one was my one that was 3 away. Well, this one's 3 away. This one's 4 away. This one's 4 away. That's a great graph. 5, negative 3x. Alright, this one's going to be easy because it's plus 0x plus 0. Awesome. So, negative b over 2a, that's going to equal negative 0 over 2 times negative 3. Anything divided by 0 is just 0. So I'm going to put 0 here. 0. Negative 3 times 0 squared is 0. That's helpful. So then let's do our little thing. 1, 2, negative 1, negative 2. Alright, so negative 1 squared times negative 3 is going to be negative 3 times 1, which is still negative 3. Negative 2 squared times negative 3 is going to be negative 3 times 4, so that's negative 12. So you're telling me right here, negative 3 times 1 squared is going to be 1, so that's still negative 3. And you can see this. If this was even a positive 2, 2 squared is still 4, and this is negative 12. Awesome sauce. So, my axis of symmetry I got was right here, because it told me x equals 0. The awesome part about this one is it starts right at the vertex, 0, 0. Then if I move negative 1, I go down 3, go over positive 1, down 3. And negative 2 is way down here off the graph. So this one, it doesn't make any sense to do extra points for because it's already off the graph. That vertex is a maximum. Awesome sauce. Word problem. The equation y equals negative x squared plus 4x plus 3 represents the height of a flying disc x seconds after it is tossed. When will it return to the ground? So, remember, when it returns to the ground in all these problems, it's y equals 0. Now, for our sake, we're going to find the x value. So, x is equal to negative b over 2a. And this one, it's a 4, so I have negative 4 over 2 times negative 1. That's going to be negative 4 over negative 2, which is 2. So my x value is 2. So I come over here. We didn't make a chart for you. So 2. If I go back, I go 1, 0. If I go forward, I go 3, 4. So let's try these. Negative 2 squared plus 4 times 2 plus 3. Negative 2 squared is negative 4 plus 8 plus 3 is going to be 7. Alright? If I do 1, I have negative 1 squared plus 4 times 1 plus 3. Negative 1 squared. Oh. Why am I doing negative 1? Anybody know? Anybody? Anybody at all? No? Alright. Anyways, it's still negative 1. Oh, it's 1. The form equation is negative 1. Okay. Negative 1 squared is negative 1. Plus 4, because it doesn't have the parentheses around it, remember. Plus 3. So that's going to be 3 plus 3. That's 6. And then if I do 0, 0 is really fun because it's 3. Right? It's 0 squared plus 0. Blah, 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 blah. Alright? And I know it's going to mirror it. So I'm just going to fill these in. 6 and 3 go together. 4 and 3. So let's look at this. I'm going to go up here. I'm going to find 0, 3. I'm going to find 1, 6. I'm going to find 2, 7. I'm going to find 3, 6. And I'm going to find 4, 3. Okay? I have a little problem right now. Does y equal 0 in any of these? No. When y equals 0, it's our x-axis. So we're not there yet. So what we're going to do is we're going to draw in our parabola. So this is going to look something like this and like this. And it's going to go on and on forever. What we noticed is it's around negative 1 where x equals 0, or y equals 0, and around 5 where y equals 0. So we have right now something that goes through -1 and 5. I'm not gonna tell you how to solve it because you don't need to know how to do it yet. So what we're gonna say to answer this question is, after it's tossed, is it at -1? Okay, that's seconds. That doesn't work. We want to know that after it's tossed, it is around 5 seconds when it returns to the ground. Okay, that's what you need to know. To the ground. And that's cursive for you. Okay, make sure you're not using that value of -1 because that's t seconds. Right? If you look, I wrote zeros all over it. Flying disk x seconds after it is tossed. So when does the value of y equal 0? At around x equals -1 and around 5 seconds. So we're just going to use the around 5 seconds. 7. A baker has modeled the monthly operation. So let's do it. Where y is the total cost in dollars and x is the number of cakes prepared. What is the minimum cost to the baker and how many cakes should yield that to cost? Well, we're going to solve it like any other one. You should be able to read this on your handout. I know it's a little tough here. X equals -b over 2a. That is -12. A negative of a -12 is a positive 12. 2 times 0.5. 0.5 times 2 is 1. So this is 12 over 1, or 12 equals x. Now, I'm going to put that in my equation. Y equals 0.5 times 12 squared minus 12 times 12 plus 150. Okay, if you use a calculator, you're going to get y equals 78. Okay, it's 144, cut in half is 72, minus 144 is -72, plus 150 is a positive 78. Okay. One thing you should note is this right here, this a value. A is equal to 0.5. That's positive. So it opens up. So that means this is a minimum for a vertex. So actually, because I found the vertex and it doesn't tell me to graph it, I'm already done with the problem. What is the minimum cost? That's what we found. It's our vertex, the baker. Well, the minimum cost is $78 with 12 cakes prepared. And y is the total cost? Look at this. Y is the total cost in dollars. X is the number of cakes prepared. Alright, those are the things you're looking for, those hint words. Alright, make sure you're trying not going to rush through this practice. This is a lot of good stuff. You're going to continue a lot of work with parabolas and algebra B. So this is something you got to hammer out and make sure you understand. I know I got a little long today. I'm sorry about that. Hopefully you guys can figure this out and go from there. Thank you for your attention.